This is my Module 1 mastery assignment.
My first topic is L'Hopital's rule, a method for determining limits in cases where direct substitution results in an interdeterminate form such as 0 over 0 or infinity over infinity. An interdeterminate form is a mathematical expression such as 0 over 0 or infinity over infinity whose values can't be determined. Here is a chart showing how to apply L'Hopital's rule. Basically, you do the derivative of the top over the derivative of the bottom when you have an expression that is 0 over 0 or infinity over infinity. My example is limit x going to 0, e of x minus 1 over x squared plus x. First, you need to determine if L'Hopital's rule will apply, and in this case it does. Then you do the derivative of the top over the derivative of the bottom. The derivative of the numerator is just e to the x, and the derivative of the denominator is 2x plus 1. Now you can plug in 0 to evaluate, and you get the limit is equal to 1.
My second topic is partial fractions. This is the process of taking a rational expression and decomposing it into simpler rational expressions that we can add or subtract to get the original rational expression. The formula for this is f of x over x plus a multiplied by x plus b equals a over x plus a plus b over x plus b, and we are solving for a and b. My example is the integral 5x plus 10 over x minus 2 multiplied by x plus 3 dx. So we separate the denominator as a over x minus 2 plus b over x plus 3, and we are solving for the big A and the big B. So we need to make sure every term has the same denominator. So we multiply x plus 3 on the top and bottom of the A over x minus 2, and then we multiply x minus 2 by the top and bottom of the b over x plus 3, so everything has a common denominator. All the denominators cancel out, so we need to find when a is equal to 0 and b is equal to 0, and this happens when x plus 3 equals 0, so this is when x equals negative 3, and then this also happens when x minus 2 is equal to 0, and this happens when x equals 2. So then we need to plug this x value back into the equation and solve for b. So we plug in negative 3 back into the equation, and we solve for b, and we get b is equal to 1. And then we plug 2 back into the equation for all the x's, and we get a is equal to 4. So then we put these values back in our equation, and we get 4 over x minus 2 plus 1 over x plus 3.